Welcome back, and this is my part 3 of indefinite integral video series. So this is rule 5. So if you haven't seen rules 1 to 4, you'll find those in videos part 1 and 2. You can click the link above or in the description. I will go through a series of examples using natural log, and then also I'll finish with a slightly more worded question with more information, trying to find the value c. Okay, let's get started. Let's start our first 3 problems. So the rule states that if you have 1 over a linear function, then the result would be natural log of that linear function, but then divided by the derivative of that, what is in the brackets there. So when we see this on these problems here, what we'll do is we'll just say that the integral of 1 over x is equal to, now it'll be natural log of x, but then what you don't see in many textbooks is they are actually dividing through by 1, okay, because the derivative of x is just 1, but it looks a little bit silly, that's why they don't write it, but you just remember to put the plus c. Now on part B, this one here, okay, we'll just go down here. Okay, we have the integral of 5 over x. Now we can write that slightly differently. We can write that as 5 times 1 over x. And we can even go one step further and just move the 5 to the outside of the integral. Okay, and that is integrated with respect to x. So therefore that would result in 5 natural log x, but again, not only is it the plus c, but you would be dividing by the derivative of what is in the bracket here, and that is 1. Now, that's why we don't usually see it, but it will come up like it does in this next part. So the integral of 2 over 3x plus 1 is equal to, now another way of writing that is the integral of 2 then 1 over 3x plus 1 dx. So now when we integrate this, what we would get is 2 times natural log 3x plus 1, but now this is important because we have to divide by the derivative of the bracket here, and the derivative of that is 3. So what I do is I just put divide by 3 at the beginning, because that is the same as timesing all the way through by 3. Don't forget your plus c, and that is our first 3 problems done. Here, so we're going to use the same rule above. The integral of this will be the same as saying the integral of 7 times 1 over 4 minus 3x with respect to x, and just like previously we're going to say 7, then natural log 4 minus 3x divided by the derivative of the bracket, and the derivative of the bracket is negative 3. So this whole expression is going to be negative 7 over 3 times by natural log 4 minus 3 plus c. Okay, so let's go ahead and do the second one now in orange. So what we have, I'm going to go straight in with this now because we've seen this multiple times. This is 1 over 2x minus 1. And then we can do these independently, right? We can separate them up and just do them independently. So it'll be 2 integral 1 over x dx. And that will just result in 3 natural log 2x minus 1 divided by the derivative of the bracket, which is just 2. So therefore we'll be dividing 3 by 2. Then we have plus, and this one here will be 2 natural log x, and dividing 3 by 1 doesn't change it, and our c. On to our last example. So in this one, we are given a bit more information. We've been told what the derivative of a function is, and we need to get back to the original function, okay, f of x. So if you haven't seen my video on integrating exponents, that was part 2. Please watch that video or look in the description for the link. But let's get started then. So we know then that if we integrate a derivative function, okay, with respect to x, that will result in the original function, right, plus c, right? So therefore then, if we are integrating, let's go and just draw a cloud around this one here. We want to integrate e to the x plus 1 over 2x plus 1 with respect to x. And what we can say is the integral of e to the x is just simply e to the x. We've just learned that that would be natural log 2x plus 1, but divided by the derivative of the bracket. So that's dividing through by 2, which is the same as timesing by a half, plus c. Now, there is some information in the question that we haven't used yet, and that is here. It says that if f of 0 equals 3, so that means then when x is 0, like the output y would be 3. So we can go ahead and use that here on this now. So I'll just draw a bubble around that and move that down. So this expression is equal to f of x. Don't forget, we integrated there the derivative to get f of x. So that's what we have now. Now it says that when we substitute 0 into this, we will get 3. So when we substitute 0 into this, we get 3. So f of 0 is equal to e to the 0 plus half natural log 2 times 0 plus 1, so it's natural log of 1, okay, plus c. Now e of 0 is actually 1, because anything to the power of 0 is 1, and we said that the output was 3. So 3 is equal to 1 plus half natural log 1, okay, plus c. Now there's a little bit more we can do here with this. We can take 1 off both sides, so that's just now 2 equals half. Now this natural log 1, I'm just going to focus on this just for a moment here. Let's just understand what that is. Natural log of 1, well, don't forget that natural log is log to base e. And what you're saying is what is natural log of 1? So what are we raising the power e by to get 1? Well, that answer is actually 0. Okay, we would raise e to the power of 0 to be 1. So that whole expression there just cancels out because it will be 0 times a half. Therefore, leaving us with the value of c, which is 2. So what I would do now is substitute that 2 back into my expression for f, and there would be my result. So just to save time, I'll draw a cloud around that, and let's get rid of that c, and let's put plus 2. And there is my result. Good luck. Thanks for watching. Don't forget to watch part 1 and 2 in the series. Smash the like button. Don't forget to subscribe, and I'll see you next time.